Good morning students. Today I am taking one more problem based on relation and function. In this question, we prove that the given defined relation is equivalence relation or not. One more extra question is added in this question. In this question, we also find the equivalent class for given ordered pair. Okay. So question is that let A equal to 1, 2, 3 up to 9 be a set and R be a relation defined on A cross A, defined by the pair AB related to ordered pair CD if and only if A plus B equal to B plus C. This means if AB pair is related to pair CD, then this implies that A plus B equal to B plus C, or if A plus B equal to B plus C, then we can write it AB related to CD. Prove that R is an equivalence. Also obtain equivalent class for the pair 2, 5. Solve. Since AB pair related to pair CD if and only if A plus B equal to B plus C. Here AB and CD belongs to A cross A. First we take reflexive. Let A, B belongs to A. We take two elements from the side A. This implies that A plus B equal to B plus A, because AB are natural number. This implies that AB related to AB. According to this definition, if A plus B equal to B plus C, that means A is connected to B and C is connected to B. So here A is connected to B and A is connected to B. So opposite direction, we take opposite direction of this definition. If A plus B equal to B plus C, we can write it AB related to CD. So here A plus B equal to B plus A. Due to natural numbers are commutative, now we can write it AB related to AB. So R is reflexive, symmetric. Let AB belongs to A cross A. Sorry. AB is the pair AB related to CD. We start with let our pair AB is related to CD. For every AB and CD are the element of A cross A. This implies that by this definition, if AB related to CD, then we can write it A plus D equal to B plus C. So A plus D equal to B plus C. These are the natural number because set A is containing the element from 1 to 9. This implies that B plus C equal to A plus D. Again C plus B equal to D plus A. This implies that CD related to AB. Again by the definition of relation. So this implies that R is symmetric. Now we want to prove that R is transitive or not. Third point, transitive. Let AB pair related to CD and CD pair related to EF. Then by the definition, A plus B is equal to B plus C and C plus F equal to D plus E. According to this definition, if AB related to CD, then A plus D equal to B plus C. Add. You are adding A plus D plus C plus F equal to B plus C plus D plus C. This implies that A plus F equal to B plus E. This implies that AB related to EF. Again by the definition of defined relation. So R is transitive. So in this question, the defined relation is that if A having the element from 1 to 9, R with the relation defined as if AB related to CD, if and only if A plus D equal to B plus C. So we take a defined relation AB related to CD, if and only if A plus D equal to B plus C. That means this relation is satisfied from both the sides. Now first, for proof that the R is equivalence, we take reflexive. A and B are the element of A. That means A and B may be from 1 to 9. This implies that A plus B equal to B plus C because all the numbers are natural number and natural number are commutative, so we can write it easily. A plus B equal to B plus C. This implies that by the defined relation, if A plus B equal to B plus C, we can write it AB related to CD. So AB is related to AB. So R is reflexive. Now symmetric, let AB related to CD. For every AB and CD are the element of A cross A. This implies that by defined relation A plus B equal to B plus C, we transfer the terms B plus C equal to A plus D, commutative law followed by the digit numbers. So C plus B equal to D plus A. So CD related to AB. This implies that R is symmetric. Now for showing that the relation is transitive, we take two consecutive relations AB related to CD and CD related to EF. According to definition, A plus B equal to B plus C and C plus F equal to D plus C. Adding both the equation, we have A plus B plus C plus F equal to B plus C equal to D plus C. D and C eliminating from both the sides, so we have only A plus F equal to B plus C. And now using this definition again, A plus B equal to B plus C, so we have AB related to CD. According to this, A related to B and E related to F, so R is transitive. Now we find equivalent. Class for 2, 5. Let 2, 5 is related to x, y. This implies that 2 plus y equal to 5 plus x. This implies that y minus x equal to 3. So related pairs are 1, 4, 2, 5, 3, 6, 4, 7, 5, 8 and 6, 9. because each of the pair satisfying this property. According, we want to find the equivalent class for 2, 5. So 2, let the equivalence class for 2, 5 is x, y. So use the definition of this relation. 2 plus y will be equal to 5 plus x. So y minus x equal to 3. Our set is given from 1 to 9. So we related pair are 1, 4, 2, 5, 3, 6. For example, 2, 5 related to 1, 4 implies that 2 plus 4 equal to 5 plus 1. 2, 5 related to 2, 5 implies that 2 plus 5 equal to 5 plus 2, etc. This is a verification that our related equivalent pairs are correct. So this is the question based on equivalent class and equivalence relation. Thank you. Students, now I am taking one more problem based on relation and function from your NCERT. The language of question saying that show that a relation are defined on a set of real numbers. Set of real numbers we know well, denoted by capital R. As R equal to ordered pair AB, satisfying the condition A less than equal to BQ, neither reflexive nor symmetric nor transitive. Here the set is defined, set of real numbers, and relation is defined just like this. Now we start the question. R equal to AB and satisfying the condition A less than equal to BQ. For every AB are the element of set of real number. Set of real number. So now first we start with reflexive. Let 1 upon 2 belongs to R. Here 1 upon 2 less than equal to 1 upon 2 cube. If we write 1 upon 2 less than equal to 1 upon 2 cube is not correct. So 1 upon 2 not belongs to R. AB is the pair will be the element of this relation R if satisfying this condition. We take one real number 1 by 2 and check that 1 by 2 is satisfying this condition or not. We write here 1 upon 2 less than equal to 1 upon 2 cube. This is not possible. So 1 upon 2 is not the element of R. This implies that R is not reflexive. Second, for checking the reflexivity, we check all those points they were not satisfying the condition, because if this relation is reflexive, it is satisfying for all values of real numbers. But here we take only one value and not satisfying this condition, so this relation is not reflexive. Symmetric. Let -2, 3 belongs to R. We take a one pair -2, 3 belongs to R. This implies that -2 less than equal to 3 cube or -2 less than equal to 27. But 3 not less than equal to -2 cube. So 3 minus 2 not belongs to R. We take one pair, minus 2 comma 3 belongs to R, satisfying this condition, but the opposite pair 3 comma minus 2 is not satisfying this condition, so R is not symmetric. Transitive. For proof transitivity, we have to check, we have two consecutive pair from our relation. So let 3 comma 3y2 and 3y2 comma 4y3. Suppose that we have to take two pairs belongs to R. This implies that 3 less than equal to 3y2 cube and 3y2 less than equal to 4y3 cube. Both the conditions are satisfied, but 3 not less than equal to 4 upon 3 cube. This implies that 3 comma 4y3 is not belongs to R. 3 comma 3y2 and 3y2 comma 4y3 are the element of a relation. Why? Because these two numbers satisfy this condition. 3 less than 2, 27 upon 8, and next 3y2 less than 2, 64 upon 27. But 3 not less than 2, 64 upon 27. Belongs to R. So this implies that R is not transitive. So in this question, the relation is defined as the pair AB will be the element of R if A less than equal to B cube. We start with the reflexive. Let any number, any real number 1 by 2 not satisfying this condition. So self pair of 1 by 2 is not belongs to the relation. So R is not reflexive. Now for prove that relation is symmetric or not, we take one pair minus 2 comma 3 belongs to R. If minus 2 comma 3 belongs to R, then this pair satisfying this condition, A less than, clearly this satisfying, but the opposite pair 3 comma minus 2 is not satisfying the condition, so R is not reflexive. Similarly, we take two consecutive pair from R, 3 comma 3y2 and 3y2 comma 4y3. Both the pairs are satisfying the defined relation, but the transitive pair 3 comma 4y3 not satisfying the condition, so R is not transitive. So this relation neither reflexive nor symmetric and nor transitive. Thank you. Hello students, now I am taking one more problem based on equivalence relation. Problem is that if A be a set of points in a plane and R be a relation defined on set A, R equal to PQ, ordered pair PQ, such that OP equal to OQ. This means distance of P from origin is equal to distance of Q from origin. This way of writing saying that distance of P from origin is equal to the distance of Q from origin. Then show that R is an equivalence relation. Also show that set of all points related to P except origin, the circle with center origin. So we start with reflexive. Let P belongs to A. P be any element from the set of points. Then we have OP equal to OP. This saying that the distance of P from the origin is always equal to the distance of P from origin. So we can write it P comma P belongs to R. According to the definition of relation, PQ will be the element of R if OP equal to OQ. So OP equal to OQ, OP equal to OP. So we can write it PP belongs to R. So R is reflexive. R is reflexive. Symmetric. Let PQ belongs to R for every PQ are the element of A. P and Q are the element of set A, which is the set of points in a plane. PQ is a pair which is the element of relation R. This implies that according to definition of this relation, OP equal to OQ, this can be written as OQ equal to OP. This means QP belongs to R. Every relation is showing OP equal to OQ, so PQ will be the element of R. So here OQ equal to OP, so QP are the element of R. This implies that R is symmetric. Transitive. Let PQ and QR. There are two consecutive pairs we are taking here, PQ and QR from the relation R. For every P, Q, R are the element of set A. This implies that OP equal to OQ and OQ equal to OR. Due to PQ and QR are the element of relation R and satisfying this condition, so OP equal to OQ, OQ equal to OR, saying that or implies that OP equal to OR. This implies that PR belongs to the R, so R is transitive. So R is transitive. This implies that R is an equivalence relation. Now we take second part of the question. Also show that set of all points related to P not origin the circle with center 0, 0. Since second part of the question. Since OP equal to OQ equal to OR and so on equal to A, let assume that if M XY be a point, then OP also equal to OM. This implies that A equal to under root of x minus 0 square plus y minus 0 square. This implies that x square plus y square equal to a square. This is circle with center 0, 0. So here in this question, a relation R is defined in the set of points in a plane defined as R having a pair in the form of P or Q, where PQ satisfies this condition, OP equal to OQ. That means distance of point P is equal to the distance of Q. We want to show that R is an equivalence relation and all of the points related to P is the circle with center origin. So for showing that equivalence relation, we start with reflexive. Let P be any point from the set of points A. then we already have OP equal to OP, because same point always having the same distance from the origin. So according to the definition of this relation, PP belongs to R, so R is reflexive. Second, symmetric, PQ, one pair we take from the relation, PQ belongs to R. If PQ is the element of this relation R, then satisfying this condition, OP equal to OQ, that means we can also write it OQ equal to OP, so QP also belongs to R, so R is symmetric. Transitive, let PQ and QR belongs to R, where P, Q, R are the element of A, implies that OP equal to OQ and OQ equal to OR. So OP equal to OR implies that according to definition, PR belongs to R, so R is transitive. So R is an equivalence relation because R satisfying reflexive, symmetric and transitive. Second part of the question, we want to show that here the set of all points, just like as P is the circle with center origin. So here we easily observe that OP and OQ and OR are the same. So suppose that the distance, if distance is A here and M be any point xy whose coordinates are xy, then OP also equal to OM. The distance OP is assumed by A, distance of origin from the point M is given by this. So x square plus y square equal to A square. This is a circle with center 0, 0. So these are some problems based on equivalence relation from your NCERT book. Thank you.